Today we're going to speak about probability and statistics. If one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. How can I understand such a thing? Now, if you have one blouse which is red and the other is green and the other is blue, and then you have three skirts which are white, blue and red, and you want to have a combination of those blouses and skirts, how many combinations of those can you have? This is what we call m times n. For example, if you have A, B, C, D, E and F, and those are m, any one of those letters is m. So I have 6 options for the letters. And I have how many for the numbers? I have 9 for the numbers. So a combination of A1, A2, A3, A4 and so on, be with all the same numbers. So I'm going to have m times n, which is 6 times 9, which is 54. That is the whole probability. Okay? That is how many times can this happen? How many times can I have a number and a letter together? Okay? How many ways can you have a letter and a number? That is what we have here. A letter and a number together, I can have 54 times. An order of n object is a permutation of the object. There are 6 permutations of the letters A, B, and C, which means I can have them in how many different ways combined together. I can have A at the beginning and then BC, and then A at the beginning and then CB. B at the beginning and then CA, B at the beginning and then AC, C at the beginning and then AB, C at the beginning and then BA. See, in this part, the order is very important, and that's why I call it permutation, where the order is important. Now, permutation of n objects taken R at a time, NPR, that is on your calculator, you write the n, and then you shift, press the P, and then you write the R. You're going to have NPR. This is n factorial over n minus R factorial. How can I get an example of that? If I have those 4 letters, and I only want to select 2 at a time, and the order is important, which means that AD is not the same as DA. They are 2 different permutations. The same with BA is not the same as AB. Each of them is different. So how many of those can I have? The whole numbers I have are 4. 1, 2, 3, 4. So that's the number I'm going to put on top here with the factorial. And then, how many places do I need? I only need to select 2 of them. So, 4 minus 2. And then, again, factorial. I'm going to have the total of 12, which is what I'm having here. So, when the order is important, I'm going to use the permutation, which is NPR. Determine how many different passwords are possible if, first, digits and letters can be repeated, digits and letters cannot be repeated. Now, if I'm going to have 6 places or 6 digits, I want to have digits and letters for a password. I'm going to have 5 of them, which are numbers, and then 2, which are letters, provided digits and letters can be repeated. Can be repeated. It means the first one can have any of the numbers from 0 up to 9. So I have 10 possibilities. The second one, I still have the 10 possibilities because it can be repeated. I still can have the 10 possibilities. I still can have the 10 possibilities. And then what about the letters? I have 26 letters, and I can have again the same 26 letters. So how many possibilities for the password do I have? 6,760,000. Okay? What if I was not allowed to have them repeated? The first, I'm going to have 10 numbers, which is 0, 1, 2, 3, up to 9. Now, what about the second part? As long as you have used one of the numbers in the first place, you cannot use it again, because it says digits cannot be repeated. So I'm going to have The second one, only 9 of them are allowed. Why 9? Because I've already used one of them here. Next place, I'm going to have only 8. Why? Because I have used already 2 in the previous 2 places. The fourth one, I'm going to have 7. Why? Because I have used already 3 numbers in the first 3 places. What about my letters? For the first place of the letters, I can use all the 26 letters. But for the next place for the letters, I can only use 25. Why? Because I have already used one of those here. So see the difference between, this is only 3,276,000. The difference between them, if you don't have them repeated, you have a bigger number than having them repeated. Permutation with repetition. The number of distinguishable permutations of n objects where one object is repeated q1 times, another is repeated q2 times, and so on. This is a rule. This rule is very obvious when you use it with letters in a certain word. For example, find the numbers of distinguishable permutations of the letters in the word success. Success has how many letters? 1, 2, 3, 4, 5, 6, 7. So the n, which is the number of letters, all together in this word are 7. How many of them are repeated? I have S, which is repeated 3 times. So I'm going to have 3 factorial, which is Q1 factorial. Do I have any other letter that is repeated? Yes, I do, which is C. How many times repeated? 2 times. So it is 2 factorial. Is there any other letter that is repeated? No. So it has only N1 and then Q1, Q2. That's what I have. 7, which is the number of the letters all together in the word. And then 3, which is for the S. And then 2, which is for the C. I get out my number, which is 420 possible ways of having this permutation. Thank you.